Hi, subscribe to this channel. Go to this red subscribe and click. And you also see this bell shape. So click on this and select all. This means you would be getting notification of all videos uploaded on this channel. Cheers. Okay, so we will start doing exponential. And kindly open your book, Exponential Functions. Do you know what is meant by exponential function? Not really? Okay, no worries. I just draw it. I just try to or something like this. It is like the pandemic, which is at the moment a function. Normally, you know what is a linear function. A linear function is which goes straight. So, if you just, if I just draw something like this, and I say, so if you see, this is our linear function. Yeah, the our so this is a linear function, which is a straight line. Yeah, and there is some function which can be, I can draw something like this which goes like this and then like this. This is a exponential function. This is exponential function. Why? So it can be something like this, it can be something like, so this is nowadays also, this is the also a concern of the state or the government with respect to the coronavirus. Why they want that? Because at the start, if you see, the gradient at the start is quite low. Let me take up. Yeah. Do you? But once it increases from this point where I am showing it, then the exponential is very high. So can you correlate this thing with the this coronavirus case, which is there? This function. Yes, try to explain it to me. Yeah, it's like this. One person infect one. So at the start, there is just one person. It infects maybe 4 or 5 people, and then 4 or 5 people they start infecting the people around them. They start. So it becomes a chain reaction. It is also in radioactivity. You know that in physics, the radioactivity. This is with the atomic bomb or something like that. So um, so so it becomes. So this, therefore, this is the exponential growth. Exponential growth is something which becomes, you are not able to handle it if it is negative. But for example, spread of disease is exponential. Also, something like radioactivity, that is also exponential. Even what you see is this interest, the compound interest. So if somebody is, let me put a color and show it to you. Let me take a yellow color. So if you see, compound interest is also, perhaps you have heard of the stories from some of the people who did buying from their credit card, and then they had so much interest to pay because the interest accumulates, so it becomes something like exponential function. You understand that, please? Growth is also this. Growth means a population growth. So initially there are more people born, then they start. So in the countries also, it's a exponential growth. Yeah, you understand that also. Although we cannot say that the population growth is exponential. Why? There are other resources which restrict that. For example, there may be a disease, there may be opportunities, less food. But in the ideal condition, if we see that there is a good health care, there is a good food, there is, so the population is also exponential growth. I hope you understand. There is no um, disease, so population will also increase as a population as exponential growth. Make sense? Okay. What is the formula for that? So we would do this and see. And so the formula here is A is equal to A naught. So E is a constant, and do you know what its value is? So yeah, yeah. is it is 2.71. Okay, and it is called E. And we have also, perhaps you have heard, there is something which is called natural log. And natural log, there are two types of log. One, we write it like this. Yeah. So this is for the base 10. Do you know what is the base 10? And there is something like this we also. This is ln, so it has the base of E. Do you know this thing? If you look at your calculator, there are two types of logs there. One is this with the base 10. So sometimes people like write here also 10. But even if it is not written, it means it's to the base 10. And similarly, there is ln. ln is with the base E. Okay. So we see that this is A is equal to A naught E K T. Yeah. So I would just give me a minute and I change the direction of my writing pad so that we are more comfortable. Yeah. Okay. And it's not that. Okay. So we have seen this formula. So the question is, what is A naught? So A is equal to A naught E raised to the power KT. So A naught is the amount present at time t, or the starting time is the amount at time t. Yeah, at any time. So the A naught is the initial amount. Sorry, this is not A t. This is sorry. A is the amount at time t. That would be at time t. While A naught is the initial amount. Do you understand this? Okay. So this is a initial amount. We will do some questions. And what is K? K is in fact the constant, which which defines the exponential growth. Do you understand this or no? Or I just go back to my and I try to make another graph. So if you see, and I would make the graph from various starting points. So this is another graph. This is another graph. Let's take a. So these all are exponential graphs. Yeah. And now we will compare it with our equation. So this is our t and this is our, you understand that? What is A naught at for this graph, for the yellow graph at 0? So it's starting from, and we say, let's say this is any value, I say A and this is B. And what is the difference between the slope of this graph, yellow and green? So what thing you think define this graph, this slope, looking at the equation? The power. And in what in power? So in the power, we have two things. I am just highlighting it. There are two things, K and T. So what would be defining this slope? No, T is the axis. So T is this axis. So T is not. This is that constant which is defining. So it means the K here for yellow is different. This is K1 and this is K2. So they both are different. You understand? Because the T is same for both of them. So it means, yeah, you understand that or no? I mean, if it is T here, where I'm saying T1, so the value of the green is something here, and the yellow for the same value is this one, where I am making a dot. You understand that? So although the T is same, but so we understand that. I hope If you not, then kindly let me know. Okay, good. So let's do one or two questions, and I would again, as always, take question from previous ATAR, um, and it is. So let me have a line here. So we are looking for a. Okay, let's do that. Um, the question is the amount. Yeah, the amount A of radioactive substance of radioactive radioactive substance. So, so we know radioactive substance has a exponential growth. R remaining after T days is given by. So this is the equation which defines how much radioactive substance is left. So this is 800 e raised to the power minus 0.0. Do you understand this question? Have you written the formula in your notes? That's important. This one, yeah, this one which I have made. Okay. So the first question is, let's take it. Yeah, yeah. That is, if you see, that's a very good question. I would say, uh, if there is something like an exponential growth and there is something like an exponential decay, yeah. So it means it's negative. So it means your this thing would be decaying. You understand that? So it means this could be even exponential growth or it can be a exponential decay. Does it make sense to you? We would do, and this minus, this is from the experiments. So you do experiments, you count, for example, in the population. If you look at the population of a country over maybe last 50 years, there is a data of census, and then you try to plot it, you would see that it is a curve which fits, and that mostly is like exponential. And that fitting would give you this K and tells you. So, countries like Bangladesh or other, or maybe Pakistan, they will have a high rate of this constant. So, they are, while countries like Norway or Scandinavian countries, it do have exponential growth, but their K would be quite low. Does it make sense to you what I'm trying to say? Yeah, you understand, or should I explain it a little more? Yeah, that gives the equation. So this is equation which is found after experiments. So seeing this amount, A, which is this is an amount which is there. Yeah. So the first question, and we do some question, and I hope it would increase your understanding. So the first part is what is the initial amount present? What is the initial amount present? Can you see what is the initial amount present? Yeah, 800. Yeah, that's good. So it is, let me take a, it is 800. That's very nice. How you found? So 800 gram, yeah, because it was given here in grams, yeah. And we understand how. Initial means you put T is equal to, as we put T is equal to 0. So if T is equal to 0, this implies E raised to the power 0 is, what is E raised to the power 0? 1. Yeah, 1, 1. Anything, any number raised to the power 0 is 1. Yeah. So it becomes, so if you see here, so therefore this implies A is equal to 800 times 1. It becomes 800 grams. So far, so good. Good. Now the second question is, so let me take another color. How much is left after 7 days? You have to tell me that. How much and left after, let me put this thing here. Let me get it. After 7 days. Do you know how to do that? Okay, can you do that? It is calculator assume. The question is, yeah, good, good, very nice. So it means 7 days. We put A is equal to 800. So we put A is equal to 800 E minus 0.04, and here we put 7. Yeah. So how much is there? You told me. So this becomes 604.6 gram. What does it mean? Is it a growth or a decay? Yeah, very nice, very nice. So although we talked about only growth, but it can be a decay also. Good, very nice. Okay. Uh, how much has delayed after decayed after 14 days? So next question is again, how much is decayed after? How much has decayed after 14 days? Can you answer this, please? Yeah, sure, sure. So, and one thing which you should be very careful, just to point out, you are doing it right. You have all, once you read the question, be very careful that the T, what are the units of T? For example, here in this question, it was clearly said that T is given in days. Yeah. So, and in the question, if the amount is given in hours, you will have to convert it into days. Yeah. So that's good. So what you have said now is A14 is equal to, once you put that, so it comes out to be 456.9 gram. What is this? It means how much is left? Can you tell me how much is left? How much the radioactive amount is left? Okay, let's go back to the question and read that. Uh, can you read the question? This equation, yeah. So it is the amount which is left. So it is giving the amount which is left. So can, looking at this, so th how much is left amount? This is decayed. So how much amount is left? Again, read the question. What is the equation giving? Is it giving the the amount of radioactive are remaining after? So it is the remaining. Yeah, yeah. This is the remaining. You are right. This is the question. So the amount left is 456.9 gram. Yeah. So how much is decayed? This is the question was not. The question was how much is, let me highlight it. How much is decayed? What is your question giving? What is this equation giving you? How much left? And does the question ask for how much is left? So the amount decayed is how much? Yeah, yeah, yeah. So the amount decayed is actually, let me write it again. The amount decayed, because we would subtract it from 800 minus 456.9. So as you said, this thing is equal to 343.1. Yeah. Okay, good. So that's so this is important to understand that the question some are normally not that straightforward. You will have to see what is there. Yeah. Do you understand what I'm trying to highlight? Okay. D. Find the half-life of this radioactive substance. Find the half-life. What is a half-life? Very nice, very nice. Half-life of. So can you do this question, please? So how you to do that? Any idea? Good. How to do that? Just very nice, very nice. So we make A as a 400. Yeah. So 400 is equal to 0.04, and now we have to find T. So it's calculator assumed, so you can do that. So it is 17.3 days. Yeah. So it means it would. So the T is 17.3 days. Very nice. 17.3 days. We understand that. Yeah. Okay. Uh, Now there is something which is we would do. So if you see, um, now this is our question. So what we were doing it, let me write the marks so that you understand. So this had 1 mark, yeah, A part. The B part was had a 1 mark, yeah, and then how much is decayed had 2 marks. Why 2 marks? Can you guess why it was? Because it has 2 parts to do. For example, first you had to find the decay, and then you had to find the amount left and then the amount decayed. So if I change the color, so I would say this was 1 mark and this was 1 mark. You understand that? Okay. And then this question had in fact 3 marks, right? And now we have the question which has the maximum marks, and that is, I am saying E part. Let me take another color, right and red. Find the rate of decay. So we are asked to find the rate of decay. Yeah, the rate of decay when 100 gram of the substance is left. When 100 gram. So let me rub it because it's not very clear. 100 gram of substance is left. This is an interesting part, and it has 5 marks. So it has 5. Yeah. So you have to see how you can do that. What is rate of decay, first of all? Yeah. So the rate of decay is very nice, very nice. Rate of decay is actually dA upon dt. Very nice, very nice. That's very nice. And we had the equation A is equal to 800 e raised to the power minus 0.04 t. Yeah. So can you help me find what is dA upon dt? Yeah, you can type, you can solve it in your notebook and then let me know. What you think? It is being times or is it a part of E? Yeah, good. We have to find dA upon dt. So 800 would be there. I mean, what we are saying 800 would be out and then we say d upon dt of E minus 0.04. You got that? Because it's a constant. So we take the constant out of the differentiation. Yeah. So I'm just, yeah, like this. So if you differentiate now, what is the answer, please? Now you have to take this thing also down. So it would be 800 times. So I'm putting a point for time minus 0.04 because it came down into E minus 0.04. Do you understand this or no? Do you remember the derivative of, yeah, let me write it that. If it, ah, let's say, okay, that's a good question. Let me go back and something. If you have, for example, y is equal to 3x square, can you let me know what is dy upon dx? This is a very basic question. Why 3 is there? So you put 3 and you had taken d upon dx of x, yeah? And it becomes 3 times 2 into x, so it becomes 6x, yeah? You did the same here. Any question to this? So what is 800 times minus 0.04? Very nice. So it becomes negative 32 times e raised to the power minus 0.04 t. So this is your dA upon dt. This is your rate of decay. You understand that? Good. So I just put it here. And now let's move to the next part. So we have found the rate of decay. Now the question was find the rate of decay. Let me bring it here. Zoom it a little down so that we are able to see the question. Yeah, here. Find the rate of the decay. 100 gram of substance is left. You understand that? So we have now we have to find when 100 gram of the substance is left. When, how to go ahead? Okay, very nice, very nice. That's the way. So kindly do that. So it's calculator assumed. So you can use that. what is you? What was the question? Let's read that because this is. Can you read the question here? E. So is it the? It says read the question and let me know what you think. Is it A or dA upon dt? Yeah, it's A. Yeah, correct. Correct. Okay, and if you put then in the d upon dt, can you let me know what is the answer then? How much is the decay? What is the rate of decay? Yeah, -4. So this is something. -4 means what is the unit? What is the unit? It's a rate. Yeah. Okay, let's look at it. So let's look at it. Let's say take a blue color. We had this now. So let me highlight it. We have gone to this part. Yeah. This is the rate of decay. Yeah. And if you want to find it at some specific value, once it was 100 gram was left, and for that, so from this equation I write dA upon dt is equal to minus 32 times, and what is e raised to the power minus 0.04t for a is equal to 100. That we found out here. uh, Here we found out this thing to be equal to 1 over 8, so I just multiply it with 1 over 8. It becomes minus 4. Do you understand that? And what is the unit? What is the unit of a? Gram. And what is the unit of t? No, read the question. At the start we have said what is the t? Days. Yeah, very nice. So it means once the 100 gram of substance is left, the rate of decay is minus 4 gram per day. Do you understand that? And let me ask you one thing. Do you think this decay is constant for the whole duration? No, it's not. So let's try to draw this just for our own understanding, that if we draw this and try to see, let's see. Um, First of all, we did some calculations. So I, with your help, I'm going to draw this. Yeah. So what is the? So this is A, and this is T. T is in days. Yeah, and A is in grams. We are told. Yeah. Okay. So what is the initial value at the start? So we take, for example, 800 here. We think this is 800 here. Let me take another color because it's already green. So maybe to have a red color. Yeah, this is 800. And this is, let's say this is 7. We say this is 5, 10. So this is around, this is 5. This is 10. So this is around, we say this is 7. Yeah. And how much is left after 7 days? I just make this 200, trying to 400. Yeah. So yeah. So this is 400. It's not to the scale, just trying to give you a understanding. So after 7 days, it's somewhere here. Yeah. Okay. How much is decayed after 14 days? 14 days is something here. Yeah, how much is decayed? We are how much is left? So we are at the moment plotting the amount left because the equation is given of the remaining amount. Yeah. So we are something like we are going something like this. And if I say this. So how much is left after 14 days? uh, yeah, 456. So it is something here like this. So it is something like this going, yeah. And then a half cycle is 17.3. It is almost here. So I would say our graph is going something like this, yeah. Okay. And naturally, it's not to the scale. You can make it in your calculator, scientific calculator. And if we see the decay rate changes with different values, so it is not something constant, yeah. So so this is something like this. We are having a year like this, yeah. You understand that? Does it make sense to you? The physical meaning, it's very necessary that the math is understood with its physical meaning. Does it make sense? Yeah, that's good. That's good. Otherwise, just crunching out the numbers, that's not purpose. So what I say is, because we would be almost at the end of our lecture, so I would say that you kindly go through your book. Can you open the book, please? There are few examples. I read the examples with you. I don't know, the book page number may be different. So can you find the example one and read what is that for me? Yeah, just, yeah. What you think, looking at the equation, is the number of bacteria increasing or decreasing? Very nice. And what is the K here? Yeah, very nice. So it's increasing. So it's, yeah. Next, read the question. Next part. Yeah. So what is meant by observation comment? At what time you mean? What would be T? Yeah, time zero. So can you, without looking at the answer, tell me what is the number of bacteria at the time it commenced? Very nice, very nice. Good. Yeah. 3 days after. So you would, okay. Here you have to understand this 12% per annum interest, and the T would be in which unit? The T would be in years, and 12 divided by 100, that is converting 12% into decimal, 0.12 would be your constant K. You understand that? So once, now read the question, please, again. Yeah, yeah. Do you understand what is asked? Can you explain? Yeah. Can you say that in your words? Yeah. In other words, you are interested to know that if you invest $1,000 now on a compound interest of 12%, when it would become $8,000. That's another way of putting this question. Does it make more sense now? Yeah. So you put it, so you are investing, so you can go to different banks and ask about their interest rate. And then you can compare that when, if you want that, oh, I have to have that much amount after this much time. So you would know how much it would be there. Okay. Next question, next example, please. And one thing is very important. One thing is very important. Can you again just read the first line of the same example? Yeah. Yeah, that's very important. This word, compounded continuously. So it means it is not compounded monthly, 6 monthly, quarterly, rather continuously, because your exponential graph is continuous. Do you understand? If it is not written this thing, you can't use this equation. Have Does this thing make sense to you? It's very important to understand this, that it is compounded continuously. If it is not written there, don't think. Yeah, very nice, very nice. So, okay. Next exercise. Okay. I hope you have understood this. If you want to look at some of the questions, I would be happy to look at with them. In the exercise, look at the exercise 6A, and if there is a question which we want to discuss, we would discuss it. Because I think we are just having 5 more minutes. Otherwise, I can revise the question, the lecture which we have up till now. But I hope it has made some sense to you, particularly correlating it with the actual world. So, do you think that we should look at some of the question of the exercise, or should I revise the lecture? Okay, let's go back to the lecture, and I would say what we have learned today. So today we learned what is an exponential function. Uh, Exponential function, and I would just take my. So the exponential function has this equation: a is equal to a naught e raised to the power of kt. If the power is positive, it means it's growth. If the power is negative, it means it is decay. Yeah. So this is an important thing which we have to see. And then we saw that A naught is the amount at time, A naught is the initial amount once you start observing it. So it may be that, so therefore, once you start observing, we take the time zero because we considered that the journey has started from this point. Does it make sense? Because naturally at that moment maybe it has started a lot earlier. I'll give the example of this pandemic of coronavirus. Once you come to know that there are some patients, you have started observing it, but it's certainly possible that in the community the virus was already there, because naturally some people have been now infected. It means the virus was already there. Yes. Hello. Okay. So we start from that initial point and we say that it t is equal to 0, and a naught is the initial amount, and then is the kt. K is a constant, and the k dictates how this exponential curve would look like. Yeah, we looked at various curves and see. Then we did a question where we tried to find the amount in this was a previous ATAR question, and as with any ATAR question, there were many parts and the degree of difficulty was different. So initial amount we found very easy. Again, one thing which is very important for the students is to read the question carefully and understand what is given and what is asked to be done. So that's very important that you do that. Um, so I would just um, would say then therefore we did the okay. Then we did a question of look at the decay half-life of the radioactive and the rate of decay when 100 gram of substance is left. So we did this today, and with this I think we end our lecture. Yeah.